Hello and welcome. Today, we're going to jump right into the absolute foundation of how data gets organized in PostgreSQL. We're going to unpack that three-level hierarchy that keeps everything neat, tidy, and super powerful: databases, schemas, and tables. Let's get to it. So just think about it for a second. How does a massive application, one with millions of users and just tons of data points, avoid becoming a complete and utter digital mess? Well, it's not magic, that's for sure. It's all about having a solid blueprint, a logical structure that brings order to all that potential chaos. And that's exactly what we're here to break down.
And here it is. This is that blueprint, our guide for this entire explainer. Honestly, the easiest way to think about Postgres' structure is with this really simple analogy. A database is a building, a schema is a floor in that building, and a table, well, a table is a room on that floor where all the action happens. Building, floor, room. Got it? Awesome. Let's start at the top.
Okay, we're kicking things off with level 1, the database itself. This is the foundation, right? The entire container for our whole project.
Sticking with our analogy, the database is the whole building. It's a completely isolated container. So the data for your school app lives in one building, and the data for your e-commerce app, that lives in a totally separate building. They don't share plumbing, they don't share electricity, they are completely distinct from each other.
Now, for the more formal definition, a database is an organized collection of data. But the really crucial part here is the DBMS, the Database Management System. You can think of that as the software, in our case, PostgreSQL, that acts as the building manager. It's the one handling access, security, and all the updates. It's the manager that stops the building from turning into that chaotic digital mess we were just talking about.
And you know, interacting with this building is surprisingly straightforward using SQL commands. To create a brand new empty building, the command is simply create database school. And when it's time to demolish it, you'd use drop database if exists school. That little if exists part is a nice safety net, by the way. It prevents errors if the database is already gone.
All right, we've got our building. Now let's head inside and see how everything's organized. This brings us to level 2, the schema.
So if the database is the building, then a schema is like a floor. And each floor can have a totally different purpose. Maybe one floor is for the sales department, another one is for analytics, and a third is just for human resources. They're all in the same building, but they group related rooms together. Technically speaking, a schema is a namespace. That's just a fancy word for a folder or a container that groups related things together. Now, every new PostgreSQL database comes with a default schema called public, but the real power kicks in when you start creating your own. So why even bother? Well, this is the payoff. Schemas let you organize your tables logically, maybe by feature or by team. You can also set different security rules for each schema, so the analytics team might only get read-only access to a certain floor. And, crucially, it prevents name conflicts. This means you can have a users table in your sales schema and a completely different users table in your support schema, and there's absolutely no problem. And just like with the databases, adding a new floor is super straightforward. A simple create schema command, and bam, you've got a brand new level in your building, all ready for its rooms.
Deleting a schema is just as easy. But this command, drop schema, it leads to a very, very important and potentially dangerous question. What happens if you try to demolish a floor, but there are still rooms, tables on that floor? Or maybe other parts of the building actually rely on its structure? Well, by default, PostgreSQL will just stop you with an error. But there's a way to force it.
And that brings us to this one word, cascade. If you run drop schema sales cascade, you are telling the database, I do not care what's on this floor or what depends on it. Demolish everything. It is incredibly powerful and, equally dangerous. It will delete the schema and every single table and object inside of it without asking you twice. So you have to use it with extreme caution.
Okay, we've come down from the building and the floor levels. Let's finally open the door to where the data actually lives. Level 3, the table. This is the room on the floor. It's the office, it's the filing room, it's the conference room. This is where the work gets done and where all the specific information is stored. Every room has a purpose. So, a table is basically a grid, just like a spreadsheet. It's got columns that define the type of information, like name, email, and age, and it has rows that represent a single record, like one specific user. This structure, living inside a schema, is where every single piece of their data finds its home.
Now, there are some key ground rules for tables. The columns are pretty much fixed when you create the table, but you can add or remove rows anytime you want. But the most important rule to remember, if you remember nothing else, is this. Row order is never guaranteed. If you need your data back in a specific order, you must use order by. Seriously, don't ever assume it's going to come back the same way twice.
Creating a table really just means defining its structure. You specify which schema it belongs in, you give it a name like users, and then you define each column and its data type, like an ID that's a number or a name that's text. You're pretty much building the filing cabinet for that specific room.
So, we've gone from the building to the floor to the room. Now let's pull back for a second and look at why this entire blueprint is so critical for building things with confidence.
What we really have here is a clear hierarchy of control. The database gives you that isolated foundation, the schema gives you the organizational blueprint, and the table gives you the structured storage for your data. Each level serves a really distinct and vital purpose.
And this is the ultimate takeaway. This isn't just some abstract theory. This three-level structure is what allows developers to build really complex applications where data is managed logically, it's kept secure, and it's organized in a way that prevents different parts of the app from stepping on each other's toes.
It's a simple but incredibly powerful blueprint for order. It's really the foundation for almost every single piece of software you use every day. So now that you have the blueprint, the only question left is, what are you going to build with it?